Hello and welcome to the Lab 7 video. Today we'll be taking a look at static routes. So let's go ahead and take a look at the topology and need a couple of gateways, so let's go ahead and stick these in. Need a couple of switches. Doesn't make any mention of gigabit, so we can just use the 2950 models. And it looks like we have patch cables in between these. And unlike the past labs that we've done, this time we will not be linking these two gateways up with patch cables. We will be using something else. So let's go ahead and shut off these devices. And we want to use a WIC2T. Let's go ahead and stick that in. We'll go ahead and fill both of the bays and we'll switch it back on. Go ahead and adjust this one as well. And we will be using a DCE cable. Once we have that, let's go ahead and take a look at the IP scheme. Nope, we left off a couple devices. Let's add a PC so we can test connectivity once we finish. And let's assign the IPs. Okie doke, let's go ahead and we'll open each one of these gateways up. And it looks like we want to name this one the 1. So let's click no. We always want to manually set these up in class. So let's go up a couple of levels, change the host name, and let's do this immediately with both of them, just so we won't get confused. Oops. Once we've done that, we'll set up the IPs. Go ahead and make these live, so we'll do no shut. Immediately we can see that the line goes up, which is good. And we'll go ahead and exit. This is something that we haven't done yet. This is the way that we connected these two devices, so we will assign the IP to this link on the side. So you can see that even though we've made this link live, it's still down because the opposite end is not live. So it won't be up until we've set this link up as well. We'll go ahead and exit. We'll go ahead and leave off at that point. We'll do the same thing with this one. Let's go into Okie doke, and you can see that now this link is up because both sides happen to be up and active, so they can communicate. So the line is up. Finished up with that one. With this simulation application, it's not too happy about setting the clock on the link, so we'll go ahead and skip that. And then we'll go ahead and move on to setting the static routes. So as it stands, imagine that this one is an office in Cincinnati, and this one is an office in Cleveland. Two distant cities. Imagine this link is via the ISP, so let's say Comcast allows them to have a link in between them, between the cities. It's two totally unique offices, and so as it stands, if we had a few PCs on this office, they would be able to communicate locally. But let's say, Cleveland wanted to communicate with Cincinnati, it would have no way of knowing how to get to it, so we need to tell it. How do you get between offices? So let's go ahead and pull this up. And the way you'll do it is IP. And so the way that it goes with this one, we'll use the question one. So anytime you type in IP route, the initial IP that you'll need to type in is the destination prefix. So let's say we want to get from the 192.168.50 LAN, which is this one, all the way to the 172.16.70 LAN, which is on this side. So we want to get to 172.16.70.0. We don't want to specify a specific host, we just want to tell it what subnet we want to get to. So this is the destination subnet, you could say. And then it wants the subnet mask, which is 255.255.255.0. This way it implicitly knows only to look at these as the subnet. Now, this is the next hop. We need to let it know how do we get to this 172.16.70 subnet. As soon as we leave this device, it's lost. So this will be the next hop. So it's simple because we only have one additional device. So we could do it one of a couple ways. One of them, we could specify the IP of the next hop, which would be this link, the 10.10.110.2. We could also specify an interface that it could leave out of, which on this one was SO/O/O, this little link. So it'll tell it, anytime you want to go to the 172.16.70 subnet, leave out of this one, and that'll take you to the destination, because eventually it'll hit this device. This device knows how to find that subnet because it homes it, and that'll get to it. So we'll go ahead and do it. We'll go ahead and do it this way. Actually, no, we'll do it by IP, just so you know. So we'll do 10.10.110.2. That is the next hop. And then we'll go ahead and just submit that command. That's good enough. So once again, we have IP route, the destination prefix, so the destination subnet, the subnet mask for that destination LAN, and the next hop IP, which is always once you leave this device, what is the next IP that you will find, which is this one. So it accepted that. Let's go ahead and we will close out of this window. Now we need to do the opposite with this one. So let's exit and let's do IP. Now the destination when we go this way is we begin at the 172.16.70 subnet and we want to get to the 192.168.50.1 subnet. So the destination is 192.168.50.0. The subnet mask is 255.255.255.0. And the next hop, as soon as we leave this device, is this IP. And what is that again? That specific one was 10.10.110.1. This one was .1, this one was .2. So it looks like it likes that one now. And at this point, we'll go ahead and we'll begin at this device. This is this PC. We'll do an IP config all. Just to double check what its IP was and what subnet it was on. So this one, once again, was on the 192.168.50 subnet. And we want to get to this one, which is the 172.16.50 subnet. So let's ping this PC. So the IP to that PC was 172.16.70.65. And just because you see one of the ping package timeout, as we've been talking about, that's not a big deal. Since this is the first time that, it's communicating, it takes it a little bit to, find its way. So we'll go ahead and do it one last time. And any subsequent times that you do it, it'll be fine. Okay, so at least we know we have connectivity from this PC in this office all the way to this one. So let's flip it. It should be exactly the same, but we'll do it anyways. We'll go ahead and ping this PC. In fact, we'll do an IP config all. This one is the 172.16.70.65 PC on the 172.16.70 subnet, and we want to get to the 192.168.50 subnet. So let's ping that PC's IP. So 192.168.50.1 was its assigned IP. This one, usually when you have communication one way, as soon as you test it the second way, it won't have that first time feeling. So, it should have all of the packets come back, which it did. So that's good news. So we have a basic setup. These two devices, they could be in opposite cities. They could be within the same building. They could be on different continents, but the same concept applies. As it stands alone without any kind of static routes, anytime you want to get from subnet to different subnet, it's lost unless you tell it exactly how to get to it. Now, we did it statically this point. You know, we can use some kind of routing protocol in the next couple of labs, but this is how you do it statically and manually, which sometimes for small setups, you know, that's not too big of a deal. That's just two static routes that we have to maintain. But let's multiply this, you know, let's say, you know, a medium to a big size company may not just have two of these, they may have thousands. Like let's say Best Buy, they have thousands of Best Buys. Suddenly, instead of just two Cisco devices, they may end up with 2,000, a few thousand, 5,000, and then suddenly maybe using static routes becomes not feasible, and then you'd want to do it in a more automatic way, but in this kind of basic setup, it's usually okay. So the next thing that we'll show you how to do, we'll go ahead and enable Telnet so we can show you how to manage these without having to actually physically plug into the device. So we'll begin on this device. Just to simplify it, we'll change the name. Should have done that at the beginning. Oops. So let's set up Telnet access on this one. So how do we do that again? We have to be in config mode, and then you have to do line VTY. We'll just open up a few of these. We don't want them all open. We'll set up a passcode, just a basic one. Use the same passcode we've been using this whole time. We'll do a no shutdown. Oops, this one looks like it's okay. We'll set in a login because we want people to be able to log into it. And let's go ahead and we'll close this. That's all we have to do. Now we should be able to go into this PC and telnet into... We could use any of the IPs on this device. We could use the inside LAN IP, which is the 192.168.50.250, you know, the actual gateway IP. We could also use this one. We'll stick it on the inside just to be consistent. 168.50.250. And as soon as we telnet into it, it tries to get into it. It sees that it's open. You know, if we hadn't enabled login via telnet, it would have said closed and it would have denied us. But since it's open, it takes us to the next step, which is to log in. We'll type in the passcode that we set, and you'll notice we kind of get the exec mode on this device. We didn't go into it this way via CLI. We logged into it remotely from this machine. So just like if when we used to be plugged into it, we can go into enable, and it won't let us into it, so we will have to add permissions to do that, but at least we have basic telnet access. We'll go ahead and we'll close out of this one. We'll do the same thing with this. We'll just set basic telnet access up. We won't go into the whole enable mode exactly. So let's just go line VTY. Let me check one thing. Okay, we'll go ahead and skip that. We'll exit. Actually, we need to go back to that. Log in. Now we should be able to do the same with this one, at least basic access. We'll go telnet. We'll use the inside LAN IP, the gateway IP, to this device. We'll use 10.10.70.250. Oops, actually that one's way off. Telnet It was 172.16.70.250. And it lets us in, so we'll do Cisco. And it lets us in. So we'll go ahead and close out of that. Let's see if we need to talk about anything else. One of the helpful things as well that we'll touch up on. Let's go ahead and exit all the way to the beginning. Show IP route is an excellent one. So we only have one static route on this device, but let's say we had multiples to multiple devices. It's kind of difficult to keep that in mentally, so you can use this command to show all of the IP routes in place. Now, we only have static at the moment, which is indicated by the S, and then we have the connected known routes to any physical interfaces that we have plugged in. So Cisco automatically makes you routes to the subnets that it knows exist. And the ones that it knows that exist is the ones that you told exist. So we typed in, the inside subnet, which was the 192.168 subnet, and then we told it about the 10.10 subnet. So it automatically had those. But then we also told it about the 172.16 subnet, which it lists inside of this. We'll go ahead and close out of that as well. You could do the same thing with this one, and you would see the 192.168 subnet listed in that one. Just like that. And then it knows of the 172.16 subnet, which is this link on down, and it knows about the 10.0.0.0 subnet, which is this link all the way to this one. And it knows about them because it's plugged into it. It doesn't know about these ones. We had to manually tell it because it's not plugged into it.